It's been a while since we've had to do some fractions, and so I want to have a little refresher video to kind of spark your memory on how to work these, because it's different. We're not in class every single day, so we're not reviewing them in class together every single day. So I just want to refresh your memories a little bit on how to work through a problem that deals with fractions. So let's work through number 1 on Thursday's Bellwork, where we are solving an algebraic equation. We're going to solve for x. So let's go ahead and write out, let's do number 1, letter A. We have x plus 4 1/5 equals 7 3/20. Okay. And we need to find out what x is equivalent to. And to do that, we need to isolate it inside our equation here. So let's go ahead and draw our upside down t so we can keep our math nice and organized. And we need to do the inverse operation in order to get the x completely by itself. Remember, the inverse operation is basically just canceling out whatever's on one side so that we can isolate whatever our variable is. So for this side, on the left side of our equation, we only have one operation here, so we're only going to have to do this one time. So we have an operation of addition right now. We need to do the inverse operation, which is just your opposite math, because remember, we're trying to cancel things out. So the inverse operation of addition is subtraction. So we're going to go to subtract 4 1/5. Now this is an equation, so we have to make sure that both sides stay equal. So if we're subtracting 4 1/5 from one side, we also have to make sure we subtract it from the other side as well, or else they won't be equivalent to each other. So let's go ahead and subtract 4 1/5 from this side. Okay. 4 1/5 minus 4 1/5 gives us 0, so we can go ahead and cross those out. And now we're just going to bring down what's left on our left side of our equation here. Well, the only thing we have left is our variable. So let's go ahead and bring that down. X. You're going to slide down whatever your sign is, whether it's equal to, less than, greater than, whatever it is, just slide it on down your t. And now we have 7 3/20 minus 4 1/5. Now I can't just take 4 1/5 from this because I do not have like denominators. And remember, we cannot add or subtract unless our fractions have like denominators. So let's go ahead and figure out what that's going to be. So I'm going to bump it down a little bit here. I'm going to rewrite 7 3/20 and 4 1/5. A couple ways we can do this. We could go ahead and convert this to an improper fraction and then find out what the like denominator is. You can do that. You're going to get some larger numbers for this one, but that is perfectly fine. But let's go ahead for the purpose of this video and show you how to calculate it without changing this into an improper fraction. Okay, we just need to know what the like denominator is. So we can take our whole numbers of our mixed number and just move those over because we don't need to change those right now. We just need to deal with the fraction part of our mixed number. So for 7, we have 7, and for 4, we have 4. All right, so now we're left with 3/20 and 1/5, and we need to find out what the least common denominator is. In order to figure that out, we're going to find out what the least common multiple is for 5 and 20. And there's a couple ways we can do that. So let's go ahead and move over here and show you a couple ways that we can find the least common multiple. All right, least common multiple. So the first way is we can go ahead and just list out the multiples of 20 and 5. So let's go ahead and list out our multiples of 20. We have 20, 40, 60, 80. Pretty sure we're going to be okay. We can stop at 80. All right, now let's go ahead and do our multiples of 5. We have 5, 10, 15, 20. And when you get to 20, you should recognize that we've already done 20. So we can go ahead and highlight those, because the first number that both of these numbers go into is 20. So our LCM is 20. The other way is to create a prime factor tree. So let's go ahead and do the prime factorization of 20 and 5. So for 20, that is not a prime number, so we have to keep going. This is an even number, and like I've told you before, any even number, I like to go ahead and start with dividing it by 2 because 2 is a prime number. So I like working with that one first. So 20 is divisible by 2, and when I do 20 divided by 2, I get 10. Like I said, 2 is a prime number, so I can go ahead and circle that. But 10 is not a prime number. We can still break this one down and factor it out. So let's go ahead and go down. It's an even number again, so let's go ahead and do 2. And 10 divided by 2 is 5. And I know 2, like I just said, is a prime number. 5 is also a prime number. It can't be broken down anymore. There's no number other than 1 that can be multiplied by another number to get 5. All right, 5 is prime, so we don't have to do anything over there. So now we're going to draw a Venn diagram. So I'm going to actually flip my, let's bring another piece of paper over. All right, so we have a Venn diagram that we can draw. And I'm going to put one denominator on this side, 20, and the other one on this side, 5. And I'm going to go ahead and write out what my factors were, what my prime factorization was for each number. For 20, we had 2 times 2 times 5. I got that because I am just multiplying all of my prime numbers that I circled when I did my factor tree here. So 20 is 2 times 2 times 5, and 5 was just 5. I'm going to go ahead and again circle any pairs that I have in my numbers here. If I was to have another 2 down here, I would go ahead and pair those up. But right now, the only pair I have is a pair of 5s. Any pair that you've circled, you're going to put in the middle. And then now we just have to put in what the other numbers are for each that don't have a pair. So for 20, I have 2 times 2, so I need to put 2 over here twice. 2 and 2. And for 5, I didn't have any other numbers, so I don't need to put anything else over here. So if I'm doing the least common multiple, I need to multiply every single number that's inside my entire Venn diagram. So for this, I have 2 times 2 times 5. And 2 times 2 gives me 4. Bring down the 5. And 4 times 5 is 20, which is exactly what we got when we listed out our multiples here. So our LCM is 20. Now I do want to take just a moment real quick while we have this Venn diagram up to go over greatest common factor. The greatest common factor in the Venn diagram are all the numbers that are shared. You're going to multiply all of those together. So since I only have one number that's shared here in the middle, our greatest common factor for 20 and 5 is 5. But let's go back to our fraction now that we have our least common denominator and figure out how we're going to change these mixed numbers so that they share that least common denominator but stay equivalent. All right, I'm going to go ahead and put down, since our least common denominator is 20, I'm going to go ahead and put 20 in my denominator for both of my mixed numbers here. And if you notice, my denominator was already 20 for 7 and 3/20. So I'm just going to pop that 3 back over because it didn't change. But if you look down on the bottom one, 4 1/5, now our denominator is no longer a 5, it is a 20. So we have to figure out, well, how did we get from 5 to 20? So you can divide, okay, 20 divided by 5 gives us 4. Or if you just want to do your multiples out, 5, 10, 15, 20, and you know 5 times 4 is 20. And what you do on the bottom, you must do on top so we can stay equivalent. So I'm also going to multiply this by 4. And 1 times 4 gives us 4. So now I have 7 and 3/20 and 4 and 4/20. I have the same denominator now. So now I can go back and subtract. I'll go ahead and rewrite this. I'm kind of running out of room here. So now I have 7 and 3/20 minus 4 and 4/20. But you've probably noticed that we already ran into another problem. I can subtract 4 from 7, but if I subtract 4 from 3, I'm going to get a negative number. And we don't want to deal with negative numbers right now. So I need to figure out how I can change this mixed number right here so that I can subtract this number from it. So let's break this down a little further so that we can get a larger number in our numerator. So we have 7 and 3/20. If we were to break this down, we know that one whole, so I know we have 7 wholes here, but let's break it down to just one whole. One whole represents 20 over 20 because any number that has the numerator and denominator that are the same number is equivalent to 1. So what I could say is I could go ahead and subtract my whole from a whole. Let me show you how that works. So I have 7 and 3/20. I'm going to go ahead and subtract one whole out of here. Okay, one whole represented 20/20. So I want to go ahead and add that back, 20/20. So that when I add this together, I get 7. So 6 plus 20 over 20 simplifies to 1. So now I have 6 plus 1, which equals 7. But I cannot forget this other fraction part of my mixed number. That is still part of this mixed number. So I have to make sure I also add that in. So I'm going to add 3/20. And now I can add all of this across and get a larger numerator here. So I have a whole number of 6. I have a numerator of 20 and 3. So I'm going to add those together and I'm going to get 23. And our denominator stays the same. So it's going to stay 20. So now I have 6/23 over 20. And let's go ahead and rewrite that new mixed number down. Now I can go in and subtract my 4 and 4/20. 4 and 4/20. Now my first mixed number has a larger numerator than my second mixed number. So now we can go ahead and do some subtraction here. So 6 minus 4, let's start with our whole numbers. 6 minus 4 gives us 2. 23 minus 4 gives us 19. And our numerator, of course, stays the same. So if we're going back to our original equation here, where we subtracted this, now that we found our like denominators and we borrowed where we can borrow so that we can subtract, x is equivalent to 2 and 19/20.